So picking up where we left off, from our normal curve model, we can use parametric statistics. Parametric statistics are powerful statistics based on certain assumptions about the population from which the sample was obtained. The analysis procedures that rest on certain assumptions. So certain assumptions need to be met. If they're violated, then you can't use parametric statistics. Then you have to use nonparametric statistics. So to use parametric statistics, which is a very powerful form of analysis, the population needs to be normally distributed. So your data needs to fit on the normal curve model. The level of measurement should be interval or ratio. When there are two or more distributions of data to be analyzed, for example, two groups of subjects are tested or one group of subjects is tested under two different conditions, the variance of the data in the two different distributions should be about the same. So similar variances, and the sample finally should be large, so more than 30 subjects. Normally distributed population using an interval or a ratio form of measurement. Variances should be similar and the sample should be large. When you use nonparametric statistics, it's when assumptions about the population cannot be met. This is also called distribution-free statistics. They don't rest on any assumptions about the distribution. So this would be a nominal or ordinal scale of measurement if the data is not normally distributed or if you don't have very many subjects. Then you use nonparametric statistics. So like I mentioned, parametric statistics are more powerful than non-parametric statistics. This means that they're more sensitive to differences in relationships, and they're preferred when assumptions cannot be met. Bivariate descriptive statistics. So far we've discussed descriptive summary statistics for one variable, but we could also look at descriptive statistics for more than one variable if we want to look at associations or relationships between variables. If we're describing relationships, we're looking at the strength and the direction of the relationship. We spoke about this a little bit before the midterm when we were talking about correlations. So the overall association among variables in a given sample. To do this, two or more sets of scores or ranks or classifications are derived from a particular sample and then analyzed. The relationship between the two variables can be described graphically using a scattergram or a scatter plot. So looking at scatter plots, we can look for relationships or correlations. If the scores on one variable tend to increase as another increases, like in A, we have a positive correlation. In B, if one variable decreases while the other increases, we have a negative correlation. And C, we have no correlation, where there's much scatter. There's no relationship. Scatter plots are useful, but they don't give a precise index of association between variables. For that, we would need to look at correlation coefficients, which are a statistic. The two most common types of correlation coefficients are the Pearson Product, which is a parametric statistic for correlation, and the Spearman rank order, which is a nonparametric statistic for correlation. A correlation coefficient has two components, a sign and a numeric value. The sign indicates the direction of the relationship. A negative sign shows an inverse relationship, and a positive sign shows a positive relationship. The numeric value indicates the strength of the relationship. A numeric value of 0 would mean no relationship. A negative value of 1 would mean a perfect relationship. If it's a negative 1, that's a perfect negative relationship. If it comes out perfect 1, then it's a positive relationship. And the strength and the direction of the coefficient are independent of one another. So here's an example of a correlation coefficient. So we have the numeric value on the left and the plot on the right. So the numeric value that get 0, we have no relationship. And then we move up to 0.5, a moderate positive relationship. And then up to 1.0, perfect positive relationship. Or we could go in the reverse, -5, a moderate negative relationship. -1, a perfect negative relationship, negative correlation. The Pearson Product is for parametric statistics, so larger samples and interval or ratio score of measurement. With the Spearman rank order, we're looking at nominal or ordinal scales of measurement. So the scores need to be converted to ranks, ordinal data, samples less than 25, so fewer than 25 subjects. That's how you decide what statistic you're going to use based on your data, whether you can use a parametric statistic or a non-parametric statistic.